Hi, welcome to the next section, Boolean indexing. In this section, we will calculate Boolean statistics, construct multiple Boolean conditions, filter with Boolean indexing, and replicate Boolean indexing with index selection. Then we will move ahead to select rows with unique and sorted indexes, gain perspective on stock prices, and translate SQL where clauses. Further, we will determine the normality of stock market returns, improve readability of Boolean indexing with query method, and preserve series with the where method. At the end, we will explore about masking data frame rows and selecting with Booleans, integer location, and labels. Let's move to the first video of this section, where we will learn about calculating Boolean statistics. In this video, we will create a Boolean series by applying a condition to a column of data and then calculate summary statistics from it. Filtering data from a dataset is one of the most common and basic operations. There are numerous ways to filter or subset data in Pandas with Boolean indexing. Boolean indexing, which is also known as Boolean selection, can be a confusing term, but for the purposes of Pandas, it refers to selecting rows by providing a Boolean value that can be either true or false for each row. These Boolean values are usually stored in a series of NumPy (ND array) and are usually created by applying a Boolean condition to one or more columns in the data frame. We begin by creating a Boolean series and calculating statistics on them, and then move on to creating more complex conditionals before using Boolean indexing in a wide variety of ways to filter data. When first getting introduced to Boolean series, it can be informative to calculate basic summary statistics on them. Each value of a Boolean series evaluates to 0 or 1, so all the series methods that work with numerical values also work with Booleans. Now let's get started with some code to see how it works. First of all, read in the movie dataset, set the index to the movie title, and inspect the first few rows with the head method. Most data frames will not have columns or Booleans like our movie dataset. The most straightforward method to produce a Boolean series is to apply a condition to one of the columns using one of the comparison operators. So let's determine whether the duration of each movie is longer than 2 hours by using the greater than comparison operator with the duration series. We can now use this series to determine the number of movies that are longer than 2 hours. For this, use the sum method. In all, there are 1,039 movies which are longer than 2 hours. To find the percentage of movies in the dataset longer than 2 hours, use the mean method. So there are around 20% movies which meet this criteria. We calculated two important quantities from a Boolean series, its sum and mean. These methods are possible as Python evaluates false or true as 0 or 1 respectively. You can prove to yourself that the mean of a Boolean series represents the percentage of true values. To do this, use the value counts method to count with the normalized parameter set to true to get its distribution. This returns the false distribution and true distribution. Unfortunately, this is misleading. The duration column has a few missing values. If you look back at the data frame output from our first step, you will see that the last row is missing a value for duration. We need to drop the missing values first, then evaluate the condition and take the mean. Also, dropping these missing values will allow us to calculate the correct statistic. So let's do it in one step through method chaining, with the drop NA method. After this, we use the describe method to output a few summary statistics on the Boolean series. Pandas treats Boolean columns similarly to how it treats object data types by displaying frequency information. This is a natural way to think about Boolean series, rather than displaying quantiles like it does with numeric data. It is possible to compare two columns from the same data frame to produce a Boolean series. For instance, we could determine the percentage of movies that have Actor 1 with more Facebook likes than Actor 2. To do this, we would select both of these columns and then drop any of the rows that had missing values for either movie. Then we would make the comparison and calculate the mean. Here's the set of code for this. Let's run. There are around 97% of movies where Actor 1 has more Facebook likes than Actor 2. Quite easy, isn't it?